Okay, so we talked about SI units, and we talked about mass, weight, and volume. Uh, we said that some units are base SI units, some of them are derived SI unit, like volume, for example, was derived SI unit, but length, mass, and temperature, these are base SI unit. So in this video, we are going to talk about density and temperature. So density is a derived SI unit, and we're going to talk about it. And temperature is one of the base SI units. So let's see the definition of density. So density is derived from the division of mass over volume. Okay, so you can divide the mass over volume and you find the density. So the SI unit for density is, so you know the SI unit for mass is kilogram, and the SI unit for volume, as we talked about it in the previous video, is cubic meter. So the SI derived unit for density is kilogram per cubic meter. But that's well, you don't have to use that unit that often. The unit that we are using more is gram per cubic centimeter or gram per milliliter. And if you want to convert that, it's 1,000 kilogram per cubic meter. So that's the formula for density, mass over volume. And if you want to use the symbol, it would be D equal M over V. That's D is density, M is the mass, and V is the volume. We can use any unit for the mass and volume, and that would be still a density with a different units. But you should know how to convert between those units so we can use the appropriate unit for a density. Okay, so last video we talked about intensive and extensive properties. So density, as we talked about it, is an intensive property, which means that it doesn't matter how much of that sample we have. If we double the sample, double the amount of the matter, we double the mass, and we also double the volume, so the density would be still the same. So density is an intensive property. Okay, so let's practice on an example to see how we can use density and find other quantities. So let me move this a little bit. Okay, so a piece of platinum metal with a density of 21.5 gram per cubic centimeter. You have to be careful with the units. Has a volume of 4.49 cubic centimeter. What is the mass? So I usually write a summary of all the given information. So we have density as 21.5 gram per cubic centimeter, and we have the volume 4.49 cubic centimeter. Okay, and what are we trying to solve for? Say, what is the mass? So we are solving for the mass. In what unit? It doesn't specify the unit, but we know the density is gram over cubic centimeter and the volume is cubic centimeter, so we can find the mass with gram. Okay, so we know that density is mass over volume. So we are trying to solve it for mass. There are different ways to rearrange the equation. I know that you can multiply this by V. Oh, let's do this by a different color. So if you multiply this by V, you can cancel these two, and you have M equal D times V. But I usually do it in a different way. You can just try both ways and see which of these two you're more comfortable with and go with that. So instead of that, let me erase this. Okay, so density equal mass over volume. Always remember that when you have an equality, and if I give 1 here, so if you multiply this cross, well, it's not that clear, but let's yeah, so if you multiply in this cross, you have d times v equal m times 1. There was no need to write m, but I just wrote it because in some other formulas, if you have something as the denominator, you can multiply it by the denominator on the other side of the equality. So you have these two as equal, so you can multiply this cross, and d times v is always equal m times 1. So since m times 1 is m, so m equal d times v. In this case, it might be easier to do with the previous method, but in the next example, that might help a little bit. So let's continue. So we are trying to find the mass, and mass is density times volume. The density is 21.5 gram over cubic centimeter times volume. It's 4.49 cubic centimeter. So the answer to these is let me see, 96.5. What's the unit? So the unit, if you can see, we have gram over cubic centimeter times cubic centimeter, so we can cancel these two and we have gram, so the unit will be gram. Let's have another example. So human fat has a density of 0.918 with this unit, gram over cubic centimeter. How much volume is gained by a person who gains 10 pounds, which is 4,500 grams of pure fat? So again, the first thing I always do is writing down a summary of the given information. So we have the density. It's 0.918 gram over cubic centimeter. We have the mass. If a person gains this pound, so we know pounds and gram is the unit for mass. So we have the mass as 10 pounds or 4,500 grams. Okay, what are we solving for? We're solving for the volume. In the question it says how much volume is gained. So we are solving for volume. And the volume unit is cubic centimeter because the density is gram over cubic centimeter. So again, density is m over v. We are trying to solve this based on m. So sometimes students make a mistake. They bring the m on the other side but leave the volume in the denominator, which is wrong. It doesn't work that way. So we have to solve this for volume. So if we do the same thing that I said in the previous one, so if you multiply these two, you have m equal d times v, and we are trying to solve it for v. So if we divide both sides for d, you can cancel d, so v is m over d, right? So we're trying to solve for volume. The mass, so we have two numbers for mass. Which of these two should we use for the mass? Well, the unit for for density is gram over cubic centimeter. So if you want to cancel the units, we cannot use pounds because there's no pound in the density unit, but we have gram. So it's better to use gram unit for mass. So we write 4,500 gram over density is 0.918 gram over cubic centimeter, and this will be 4902 cubic centimeter. So you might say, why is the unit of volume is cubic centimeter? So you know that when we have division by the ratio, by the fraction, it's just like saying gram times the reciprocal of that fraction. So it's like it's times cubic centimeter over gram. So then you can cancel the grams and you end up with the cubic centimeter. Okay, so the other quantity we want to talk about is the temperature. We know that the SI unit for temperature is Kelvin, and to convert Kelvin to, or let's say to convert Celsius to Kelvin, you can just add 273.15 to Celsius, and that will be Kelvin. So as you can see in here, 0 degrees Celsius, which is the freezing point of water, is 275 degrees Kelvin, and the boiling point of water is at 100 degrees, so it's 373. You just add 100 to that. So it's pretty simple for converting between Celsius to Kelvin. For Fahrenheit, it's a little bit different. So you have to memorize this formula here, and the way I memorize it is so this ratio 5:9. I've got it from someone and it just sticks into my mind, so I think it might help you. So you always hear about 9 to 5 jobs, so it's 9 to 5, so it's always 9 over 5 times Celsius. So 9 over 5 times Celsius plus 32, and this 32 is the freezing point of water. It's because if the water freezes at 0 degrees Celsius, it is 32 degrees Fahrenheit. So if you put 0 here, it just take this out, and it will be 32 degrees Fahrenheit. So let me erase this. It's too many things in here. Okay, so we have to memorize this formula for converting Fahrenheit to degrees Celsius, or vice versa. So 0 degrees Celsius, the freezing point of water is 32, and the boiling point of water is 100 degrees Celsius and 212 degrees Fahrenheit. So let's have an example to see how we can work with this formula. So we want to convert 172.9 degrees Fahrenheit to degrees Celsius. So we have to solve this for degrees Celsius first. So the first thing we want to do is to subtract 32. Well, we have to write it here, subtract 32, and I have to erase this. Okay, so then we have degrees Fahrenheit minus 32 is 9 over 5 degrees Celsius. Okay, so we can have these two cancelled. Then you want to get rid of this, so if I multiply this by 9 or 5 over 9, the same thing, 5 over 9. Okay, so we can cancel these two, and then we have 5 over 9 times, and we have to multiply that to both of these. We cannot do it just for Fahrenheit, equal degrees Celsius. Okay, so we have Fahrenheit as 172.9, so this times 172.9 minus 32 is degrees Celsius, and the answer to that is 78.3 degrees Celsius. So converting between Fahrenheit and Celsius, you have to memorize this formula. Between Celsius to Kelvin, it's easy. You just have to add 273.15 to degrees Celsius. So that plus degrees Celsius is Kelvin.